Hi, in this video I'm gonna talk about integration by parts and focus on the problem type that using trig formulas. So let's begin. Here is our formula. Basically, as I mentioned, we surely want to find u and dv first, which is from our question. Okay, so based on this u, I'm gonna derive du, derivative of the u, and based on this dv, I'm gonna derive v, antiderivative, right? So let's see the formula. Integral u dv equals u multiply v, this direction, minus integral v du, this column, right? Let's see problems to apply this. Okay. So as I said, in this video we're gonna focus on the trig formulas. So the problem's gonna look quite similar like this: arcsine, arctangent, secant square, something like that. So let's clean this. Here, I surely know I want to find u and dv first. I call this column old column. It's because everything in this column I directly find from my question, directly from here. Let's see. Okay. Recall our formula. I think I remember this. Arcsine x, I know its derivative equals 1 over square root 1 minus x squared, right? Dx. So, okay, I know if I find u, I'm gonna do derivative, find du. If I find dv, I'm gonna do antiderivative, right? So I surely want to put this arcsine into u position. So I say u equals arcsine x, and then du. So I can apply my formula, which is 1 over square root 1 minus x squared dx. Okay, so as I said, this column is old column, which means everything should from my question, right? I already have this arcsine x, so what is left in? Dx, right? So I put it here at dv. Say, if I put this arcsine x and the cosine arcsine x and the dx back together, I exactly get my question, right? Arcsine x dx. They should match up. So that's the reason I call it old column. So based on this old column, I find this column, which is the new column, right? Everything in this column is derived from my old column. So based on dv, I find v is simply x, right? So I can go back that derivative of x is dx, right? 1 dx. Okay, apply formula. Make it clear. Go here. Equals uv, this direction, right? X by arcsine x minus integration new column x by 1 over 1 minus x squared dx. Okay, so it's fairly simple to set it up. So x arcsine x minus, okay, I put x dx on top. Here is 1 minus x squared. Okay, so to solving this, I'm gonna use substitution. Say u equals 1 minus x squared, and then du gonna be negative 2x dx, right? See, I find x dx which match up here, right? Based on this, I know x dx equals negative 1/2 du, right? Plug in. So x arc sine x minus, here is square root u, right? On top is negative 1/2 du x dx, right? So I keep rewriting it. I take this constant out, so x arc sine x plus 1/2 negative minus and integral 1 over square root u du, right? So keep rewriting. X arc sine x plus 1/2 integral u to the negative 1/2 du, right? Let's see here. I know that square root u is u to the 1/2. 1 over u is u to the negative 1. So 1 over square root u. Inverse of the square root u, right? U to the negative 1/2. So which is here. This equals x by arc sine x plus 1/2. 1/2 is copying from here, and u to the 1/2 multiply 2 plus c. Okay, so I wanna see this part. I want to see if I can go back to here. See if I'm right? So I want to do u to the 1/2 by 2 derivative, which is 2. I put a constant here, multiply 1/2 u. Here is 1/2 minus 1, right? The power minus 1, negative 1/2. So I already multiplied the power here. This 2 can be cancelled out, which is u to the negative 1/2, right? So I come back, which means it's right. Okay. 1/2. So I'm not finished because my question is about x, right? My variable is x, so I don't want to forget to plug it back. X arc sine x plus u to the 1/2. U is what? Here, right? It's a substitution u. So plus 1 minus x squared to the 1/2 plus c. This cancels out, right? So this is my final answer. Okay. Let's see next one. X cosine x. So same here. I always want to find u and dv first, which is directly from my question. So if I put u equals x, and what is left? Cosine x dx, right? I directly copy from my question. Put them together, go back. Yes, old column. So based on my old column, I find du is dx. V is sin x. Sin x derivative cosine x dx, right? So apply formula, which equals uv, this direction, x sin x minus integration new column, sin x dx. Okay, so x sin x minus, this is what? Negative cosine x, right? Because cosine x derivative is negative sin x. So here I need to put a negative sign. plus c. So x sin x plus cosine x plus c. This is my answer. Okay. Let's see next one. X secant x squared. As long as I see secant x squared, I have a sense that I know tangent x prime equals secant x squared, right? This is our formula. So, okay, I know I still want to find u and dv from my question, and I surely want to put this part into dv, right? Secant x squared dx is because I know v is simply tangent x. I do derivative, goes to here. So what is left? X, right? Here. Du gonna be dx. Apply formula, which equals uv, this direction, x tangent x minus integration new column tangent x dx, which is here. Remember how to solve this? So x tangent x minus integration, I want to rewrite it into sine over cosine, right? So here, substitution, u equals cosine x, du gonna be negative sine x dx. Plug in x by tangent x minus 1 over u, negative du, right? Because what is here, sine x dx, but the du is negative sine x dx, right? So I take this negative 1 out, which is x tangent x plus 1 over u du. Okay, so this part comes again, equals x tangent x plus natural log absolute value u, right? You never want to forget this absolute value, and then plus c. So I haven't finished, I have to plug this u back, right? So x tangent x plus natural log cosine a cosine x absolute value plus c. So this is my final answer. Okay. So for now, we have a sense that I see something looks like related to some formula I know. I can put it at the right position, right? I know I'm gonna do derivative or antiderivative later, right? So let's see this one. Okay, I see this arctangent. The formula I know is derivative of the arctangent, right? So derivative of the arctangent x is 1 over 1 plus x squared. Okay. So u and dv. I want to do derivative, so I put arctangent x squared here. Right? I surely want to put it at the u position, which means du gonna be 1 over 1 plus. I see here arctangent x derivative is 1 plus x squared, right? Here is x squared inside, so this is gonna be x squared square, right? And I don't want to forget the chain rule, which is x squared prime. So I need to solve this 1 over 1 plus x to the 4th by 2x dx. So what is left here for dv? X dx, right? So v is 1/2 x squared. We have to be careful. Don't forget this dx. It always comes with dv, because derivative function always follows a derivative function. Here is same thing. Derivative function follows a derivative function. You simply remember as d follows d and d match up with d. So we won't forget it. This equals uv, right? 1/2 x squared arctangent x squared, right? Minus integration new column, which is 1/2 x squared by, I put this on top, 2x dx over 1 plus x to the fourth. Simplify this. So this goes to here, 1/2 x squared arctangent x squared minus this 2 with this 1/2 cancel out, right? So this is x cubed dx 1 plus x fourth. Okay, I see the highest power on x is 4, right? What's on top? X cubed dx. So substitution. U equals 1 plus x to the fourth. So du is 4x cubed dx. So based on this, x cubed dx equals 1/4 du, right? Divide this 4 to here. Du plug in, which equals 1/2 x squared arctangent x squared, copying this part, minus top is 1/4 du, the bottom is u, right? So rewrite it, 1/2 x squared arctangent x squared minus 1/4 1 over u du. This comes again. So it equals 1/2 x squared arctangent x squared minus 1/4 ln absolute value of the u, right? What is u? This is a substitution u, right? 1 plus x to the fourth plus c. Okay, so this is my answer. So basically, if the question looks like you have to use trig formulas, which I already said in the previous video, we have to be very familiar with these formulas. And also we should have a sense what I want to do later. I want to derivative or antiderivative to make sure which position I want to plug it in, right? And then the rest part you only copy from your question to get your old column. So set it up and simply you can solve it, okay? So wish this helps and see you in my next video. Bye.